Okay, so the second part of 2.1 is talking about interval notation and domain, what the domain or the domain restrictions are. So lucky for you, interval notation is quite easy. Sometimes it's easiest to go ahead and graph it first, graph your inequality, and then use the interval notation symbols. Okay, so let's start with interval notation. So interval notation is just that. It's a way to notate or show an interval of numbers. So for instance, if you had a number line and we had between -3 and 2, so here's 0 in the middle, and we had all values including -3, so it's a solid dot, and it's all the values in between -3 and 2. But notice I have an open circle over the 2. That open circle indicates that it does not include the 2. So it includes everything up to the 2, but not including the 2. Where this one is including everything up to the -3 and including the -3. So when you're including something, when you're including a value, you have a solid dot. The solid dot in interval notation is represented as a bracket, okay? So solid dot, we're going to use brackets. Open or in infinity signs, you're going to use parentheses. Okay, so solid means we're including it. Parentheses means we're not including it, or it's an infinity sign, excuse me. Okay, so if I were to ask you to write this, if this was written in an inequality, what you would say is x is all the values, so the unknowns are all the values in between -3 and 2, but it doesn't include 2, okay? It includes -3, but not 2. So with interval notation, or I'm sorry, with inequality notation, it would be x is going to be greater than and equal to -3, but greater than 2. Sorry. I did them backwards. Sorry. Okay. It's going to be x is going to be greater than or equal to -3, but less than, sorry, I had it backwards, less than 2. Okay? So that's with an inequality. With interval notation, it's actually much easier to write. Since we're including the -3, we have a solid dot, we're including the -3, I'm going to put a bracket, -3, comma, up to 2, but not including 2. So I'm going to put a parenthesis. Okay, so bracket means it includes it. Parenthesis means it doesn't include it. Okay, so let's try another one. If we had a number line, and let's say I had 4, and we're going to have all the values larger than 4. That's what this number line is saying. All the values larger than 4. So with an inequality, it would be x is greater than 4. So notice I have an open circle over 4. It doesn't include it. So it's everything bigger than 4. It doesn't include 4. With interval notation, since I am not including the 4, I'm going to put a parenthesis all the way up to infinity, parenthesis. So an infinity sign is just a sideways 8, 2 circles side by side, however you want to draw it. So infinity does not stop. So that's why we use a parenthesis. Okay, let's try one more with interval notation. Let's say I have the number 2, and it's all the numbers less than that. Okay, so with an inequality, it would look like this. All the values are less than or equal to 2. As an interval notation, so remember, we're always going to go low to high when we write interval notation. So the low numbers means we're going to negative infinity. So we have parenthesis, negative infinity, because we're going in the negative direction. And we're going up to the number 2. And we are including it. So we're going to do a bracket. Okay, so that's interval notation. So where we would use this is when we are looking at domain restrictions. So domain is just another way to say our x values. So in other words, what are the numbers that we can use for x? So with domain restrictions, there's really 3 restrictions that we're going to be limited to. if you have a function and it's just your basic polynomial, okay? Just your basic polynomial. The domain says, what are the values that I can use for x? That's what the domain is asking for. So when I look at this, I look at these places where I can replace x with a number, and there's really no restrictions at all. So when I have just your basic polynomial, right, there's no fractions, there's no radicals, it's just a basic polynomial, 4-term polynomial in this case, I can use anything I want. So I can have any value for x. Doesn't matter. There's no restrictions. So with this one, my interval notation, so my domain would be all the values from -infinity to +infinity. Okay? That's written in interval notation. -infinity to +infinity. If I were to write it, just write it out, I could write it as all reals. So when I have just a basic polynomial, it can be a trinomial, it could be a binomial, just anything without fractions and without radicals, then my domain is going to be all reals. All reals, -infinity to +infinity. Where the restrictions come in is when we're dealing with fractions. So at this point, there's 2 restrictions that we have to worry about. There's actually 3, but since we're not there yet, I won't bring it up. So there's 2 basic restrictions. One is when we have a fraction. Okay? That means there's going to be a problem. Because if I have the fraction 3x plus 1 over 0, do you see what the problem is? You cannot divide by 0. 0 means it's undefined. Okay? That's a restriction. So what happens is if you have a fraction, so let's say we have the function f of x equals 3x plus 1 over x plus 1. Well, the minute you see you have a fraction, now you have to set the domain, because the domain is going to be important, because there's all kinds of values that I can use except 1 in this case. Okay, so here's how you're going to deal with fractions. You're going to take the denominator and you're going to set it to not equal 0, because you cannot have a 0 in your denominator. So you're going to say, okay, the top can be anything I want. I can have 0 in the top. That's okay. It's the denominator that gives us trouble. So we have to set the denominator to 0 and solve. So I'm going to subtract 1 from both sides. So my domain restriction says I can have any value except -1. Because if I plug -1 into here, I'm going to get 0 for my answer, or for my denominator. That won't work. So my domain restriction is all reals except -1. Now, if we were writing this on a graph, this is what it would look like. Here's my number line. I can have all values up to, but not including -1. Okay? So it's all the values up to, but not including -1. So interval notation, I'm going to have this value. So I have -infinity up to -1. And I'm going to union, or and, that's another way to say and, all my values from -1 to infinity. So it's all of these values, that's my restriction. Okay, so it depends on how the question is asked. If it asks for what's the domain restriction, the domain restriction is x cannot be -1. If it says what is the domain, this would be my domain in interval notation. It's telling me all the values that I can use for my domain or for my x values. Okay, so that's your first restriction. Fractions. Fractions will cause problems. Set the denominator to 0 and solve. The second restriction is when you have a radical. Okay, so a radical means like a square root, cube root, fourth root, something like that. So if I had the function f of x equals square root of 2x plus 1. Okay, so a radical also causes problems. You cannot have a negative underneath a radical. If we have a negative underneath the radical, now we're working in the complex number system instead of the real number system. So we're setting that domain restriction of you cannot have a negative underneath your radical. So if this is the case, if I have a radical, what I'm going to do is I'm going to take the number under the radical, so the integrand, and I'm going to set that to greater than or equal to 0. Because I can't have 0 under a radical. 0 is fine. But I want all values that are positive, and that's what this means. Positive values and 0 are completely okay underneath the radical. So here's my inequality. I'm going to solve it. Divide by 2. So I get all values are greater than or equal to negative 1/2. Now remember, real quick reminder, if this was a negative value of 2, and I divided by a negative, remember you have to flip the sign, okay? So on a number line, it's going to look like this. All values that are equal to or greater than negative 1/2. Interval notation, it's going to look like this. I'm including the negative 1/2, and it's going all values greater than negative 1/2. Okay, so that's your domain restrictions. 2 restrictions for now. As we get further in, when we get into logarithms, then you can't have a negative logarithm, but we'll hold that for now. So 2 restrictions. When there's a fraction, you set the denominator to 0, or to not be 0, to not equal 0, and solve. With a radical, it has to be greater than or equal to 0. Okay.